Welcome guys, today I'm going to be solving a problem which I believe is a wonderful review of the many properties of logarithms. So if you want to review these properties, pause the video, solve the problem on board by yourself, and then come back to it once you have done it and I will show you the solution. So I will solve this problem on the left side of the board, and after on the right side I will write down which properties are being used. So let's begin. We see that 60 to the power of a is equal to 3, 60 to the power of b is equal to 5, and our goal is to find this scary exponent. Okay, so first they want in the exponent we see there's use of a and b, so to get this a out of the exponent we have to convert this to logarithmic form. So above is the same as writing log 60 base 60 of 3 is equal to a, and the log base 60 of 5 is equal to b. Wonderful. And that is simply by definition of logarithm. Then we have to evaluate this power, so I'm going to forget about the base of it for now and just look at the exponent. We have 1 minus a minus b over 2 minus 2b. We can instantly factor that as 2 times 1 minus b. Pull out the 2, factor it simply. Alright. So this, we have our a's and b's, some other constant numbers, and we have above here the logs as a and b. So let's just substitute it. 1 minus log 60 of 3 minus log 60 of 5 over 2 times 1 minus log 60 of 5. Just from the statements we have above. Alright, not bad. And I think we can do this even better by saying that 1 is log 60 of 60. Log 60 of 60 minus log 60 of 3 minus log 60 of 5 over 2 times log 60 of 60 minus log 60 of 5. Great. And then we can simplify this even more by using our division property. Log 60 over 3, that's 20, and divided by 5, that's going to be log 60 of 4. And 2 times log 60 of 5 minus log 60 of 60 minus log 60 of 5. Again, divide, it's going to be 2 logs 60 of 12. I believe 6 divided by 5 is 12. Very good. That is, forgot that equals, that's equal to log 60 of 4 over log 60 of 2 squared, which is 144. And by change of base formula, we have that is equal to log 144 of 4. So great, that's our exponent, simplified. So to evaluate this, we plug back our simplified result. 12 to the log 144 of 4. These are very nice numbers because they are just powers of, they're just numbers which have the exponent of 2. So 12 to the power of log 12 squared, 144, of 2 squared, 4 to the 4. By another rule, these numbers cancel. We have 12 to the power of log 12 of 2, because we both have these powers, they are removed. And by our last property, this number to the power of the log in the same base is 2. And that is our final answer. Alright, so hopefully this made sense, but if not, let's go back and look at the properties being used. So, for the first property I think we saw is this one. This is the first step. I'm going to list them here. And this is going to be the just definition of logarithm. Okay? How do we convert exponents to log form? Exactly like that. Alright, the second step, which was right here, this was step 2, we used substitution here, I believe. Okay, never mind, not this step. Sorry, this was step 2, where we converted this into division. See, we have log 60 minus log base 60 of 60 minus log base 60 of 3, and then minus log base 60 of 5. When you have logarithms with the same base subtracted, you just divide the argument they have. So okay, it's going to be subtraction property, where I'm going to write it out, where it's given that the log n of a minus log n of b is equal to log n of a over b. Alright, that's simple enough. So we used it both here, we got our results by dividing. Then what's happening here? This is our third property, this step, where we have 2 log 60 of 12. When we have some number outside of the logarithm that's being multiplied by it, that's the same as having a power. That's going to be, I don't even know the name of it, I think, the power property or something, where you have some a log n of b is equal to log n of b to the power of a. Alright, good. So that's what we did here. We put 2 in the exponent as the exponent of the argument. And then here we have our step 4, which is the change of base rule. Okay, change of base, where we have, if you have some log a to the b, it is equivalent to log of any base b over the log the same base of a. Alright, so that's what we use here. We have the log 60 as the base. We just put 144 as the base of our logarithm, of the base of our new logarithm, and 4 as the argument by this change of base rule. Then we have only 2 more steps. I believe this was our 5th step, where we got 12 to the power of log 12 squared argument 2 squared. When there's a base with a power and an argument with the same power, those powers are indifferent to us. So let's not call it anything. If we have a log of a to the n argument b to the n, it's equivalent to log a of b. Powers get cancelled. And our final property was the last one we used. When you have some number to the power of a logarithm with base n, then the logs and the number, the base, which is the exponent, they get removed. So if you have n to the power of log n of a, that is equal to a. And that is it. We used a few properties here, quite a bit actually, and hopefully this problem helped review the properties of logarithms. Thank you for watching.